NASA has unveiled a new plan to reach the Moon's south pole. The agency is once again partnering with Firefly Aerospace, which to date is the only American company to have successfully landed a spacecraft on the lunar surface. That success came earlier this year in March, when Firefly's Blue Ghost 1 touched down during its maiden mission. Landing at the Moon's south pole, however, has proven much more difficult for NASA and its commercial partners. Another U.S. company, Intuitive Machines, has attempted the feat twice in the past 2 years and failed both times. By comparison, Firefly's first landing was in the northern hemisphere of the Moon, a relatively straightforward achievement when set against the rugged terrain and deep, shadow-filled craters of the South Pole. Still, NASA clearly believes Firefly is up to the challenge and has entrusted them with at least 2 high-value payloads for this next mission. The Blue Ghost lander will deliver a pair of new lunar rovers to the South Pole. The first, named Moon Ranger, is being developed by NASA's Ames Research Center in partnership with Carnegie Mellon University. Roughly the size of a carry-on suitcase, Moon Ranger is designed to autonomously explore the region in search of water ice. Its stereo camera system will generate 3D maps of the lunar surface, enabling it to operate with full autonomy, even in the absence of communication with Earth. The second rover comes from Canada and is still awaiting an official name. Similar in size to Moon Ranger, this 4-wheeled platform represents the Canadian Space Agency's first major contribution to lunar exploration beyond their renowned robotic arms. Like its American counterpart, the Canadian rover will hunt for signs of water ice while also monitoring radiation levels and temperature changes at the South Pole. What makes this rover especially interesting is its hybrid power system, solar panels combined with a large battery pack. This allows it to venture into permanently shadowed craters where sunlight never reaches and operate in total darkness for up to an hour. These craters are prime candidates for harboring significant water ice deposits. The design also means the rover should survive the Moon's 2-week-long nights and reactivate for another cycle of exploration. Beyond the rovers, Blue Ghost itself will carry 3 scientific instruments. Among them is the Laser Ionization Mass Spectrometer. This device will use a robotic arm and scoop to collect samples of lunar regolith. It then blasts those samples with a laser, breaking the material down to analyze its composition at the atomic and isotopic level, providing an exceptionally detailed picture of the Moon's surface chemistry. Just like earlier American lunar landers, Blue Ghost will be equipped with NASA's stereo cameras for Lunar Plume Surface Studies instrument. This is part of NASA's ongoing research into how spacecraft interact with the light, dusty regolith that blankets the Moon's surface. Similarly, the lander will carry NASA's Laser Retroreflector Array, which allows scientists on Earth to fire a laser beam at the spacecraft and receive an accurate reflection back. This enables an extremely precise measurement of where Blue Ghost ultimately lands. The South Pole mission is scheduled to launch as early as 2029 and will be Firefly Aerospace's most ambitious challenge yet. But it won't be their only follow-up journey to the Moon this decade. Even before the success of Blue Ghost 1, NASA had already selected the company for additional commercial lunar payload missions. The next mission, Blue Ghost 2, is set to launch next year and will target the far side of the Moon, often referred to as the dark side. Of course, it isn't truly dark, it simply remains out of view from Earth. Still, the far side is vastly different compared to the near side we are familiar with. Blue Ghost 2 will first deploy a European communications satellite, Lunar Pathfinder, into lunar orbit before descending to the far side surface. Once there, it will deliver the Lunar Surface Electromagnetics Experiment, LUCI-NIGHT. This instrument will perform radio astronomy, using the Moon itself as a shield against Earth's constant radio interference, to obtain clearer observations of the early universe. Then, in 2028, Blue Ghost 3 will travel to one of the Moon's most mysterious regions, the Gruhoisen Domes, located in the northern hemisphere. These unusual geological formations have puzzled scientists for decades. Most of the Moon's surface geology was created by thin basaltic lava that spread out like oil, leaving few prominent features. In contrast, the Gruhoisen domes seem to have formed from thick silicic lava, which flows more like peanut butter and hardens into dense granite-like rock. Here lies the mystery. On Earth, silicic lava is only found in regions where tectonic plates collide and where water is present. The Moon, however, has neither tectonic activity nor liquid water. By current understanding, these domes shouldn't exist at all, which suggests some unknown geological process is at work. To investigate, Blue Ghost 3 will carry 6 scientific instruments, some of which will be deployed on a rover built by an as-yet unnamed commercial partner. While the provider remains uncertain, a promising new rover design was recently revealed as a collaboration between 2 American companies, Intuitive Machines and Astrolab. It's designed to locate and extract a rare element on the Moon called helium-3, a potential fuel source for nuclear fusion that could, in theory, provide Earth with nearly limitless energy. The vehicle itself is built on Astrolab's Flex rover platform, which will tow a resource harvesting device being developed by Interloon. Before leaping straight into large-scale lunar mining, the 2 companies plan to send a test rover as early as the end of this year. That rover will be delivered to the Moon's surface by Astrobotic's Griffin lander, currently scheduled for launch in November aboard a Falcon Heavy rocket. For this first mission, Interloon is outfitting the Flex rover with a specialized camera created in collaboration with NASA. This instrument will help the team estimate how much helium-3 may exist in the lunar regolith. In practice, the rover will be searching for titanium-rich minerals which are believed to correlate with the presence of helium-3. Finding one is likely to mean finding the other. Once Interloon gains a clearer picture of the resource potential, the company plans to deploy a follow-up rover in 2027. That second mission will focus on sample collection in what they describe as prime harvesting zones. At the same time, Interloon is already working on lining up potential customers for future helium-3 shipments. In May, the company announced a partnership with the U.S. Department of Energy, which agreed to purchase up to 3 liters of helium-3 by 2029. Interloon also revealed a deal with the quantum computing startup, Mabel, which has committed to buying thousands of liters annually between 2029 and 2035. This highlights helium-3's broader applications beyond fusion power, ranging from quantum computing to national security technologies and even advanced medical imaging. While some helium-3 can be extracted on Earth, the quantities are extremely limited. Meeting projected demand will almost certainly require lunar sourcing. For now, Interloon is still a small startup with roughly 25 employees, yet the company is positioning itself to become the first U.S.-based commercial mining operation on the Moon. And they don't intend to stop at helium-3. Interloon also has ambitions to harvest industrial metals, rare earth elements, and even lunar water to sustain a long-term human presence. Exactly how they will achieve this remains unclear. The company claims to have patent-pending technology that allows them to deploy smaller, lighter systems to the lunar surface, requiring up to 10 times less power than comparable alternatives. That promise alone has already secured more than $18 million in early funding. If anything, this could be the first real sign of an impending lunar gold rush. Should companies like Firefly succeed in delivering reliable, affordable landing platforms capable of reaching any chosen location on the Moon, then the resource industry will surely follow. For now, scientific exploration may take priority, but make no mistake, there is wealth on the Moon, and people are determined to figure out how to claim it.